Hello everyone. Today we will talk about gesture recognition. Uh, Actually, we will implement gesture recognition, but firstly, we need to learn gesture recognition. What is this? How can I use? Uh, which sector using this technology? So, gesture recognition is a topic in computer science and language technology with the goal of interpreting human gestures via mathematical algorithms. It is a subdiscipline of computer vision. Gesture can originate from any bodily motion or state, but commonly originate from the face or hand. Focuses in the field include emotion recognition from face and hand gesture recognition since they are all expressions. Uh, Users can make simple gestures to control or interact with devices without physical touching them. Many approaches have been made using cameras and computer vision algorithms to interpret sign language. However, the identification and recognition of posture, gait, proxemics, and human behaviors is also the subject of gesture recognition techniques. Gesture recognition can be seen as a way for computers to begin to understand human body language, thus building a better bridge between machines and humans than older text user interfaces or even graphical user interfaces, which still limit the majority of input keyboard and mouse and interact natural without any mechanical devices. The major applications areas of gesture recognition in the current scenario are automotive sector, consumer electronics sector, transit sector, gaming sector, to unlock smartphones, defense, home automation, automated sign language translation. Gesture recognition can be conducted with techniques from computer vision and image processing. The literature includes ongoing work in the computer vision field on capturing gestures or more general human pose and movements by cameras connected to a computer or something like that. Gesture recognition and being competing reduce the hardware impact of a system and also increases the range of physical world objects usable for control beyond traditional digital objects like keyboards and mice. The term gesture recognition has been used to refer more narrowly to non-text input handwriting symbols, such as inking on a graphic tablet, multi-touch gestures, and mouse gesture recognition. This is computer interaction through the driving of symbol with a pointing device cursor. Gesture types. In computer interfaces, two types of gesture are distinguished. We consider only gesture, which can also be regarded as direct manipulations like scaling and rotation, and in contrast. Offline gestures are usually processed after the interaction is finished, etc. A circle is drawn to active a content menu. Offline gestures, those gestures that are processed after the user interaction with the object. An example is a gesture to act to a menu. Online gestures, direct manipulation gestures, they are used to scale or rotate a tangible object. Touchless interface, a touchless user interface in an emerging type of technology based on gesture control. Touchless user interface, the short meaning TUI, is the process of commanding the computer via body motion and gestures without touching a keyboard, mouse, or screen. Touchless interfaces, in addition to gesture control, are becoming widely popular as they provide the ability to interact with devices without physical touching them. Type of Types of touchless technology. There are several devices utilizing this type of interface, such as smartphones, laptops, games, TVs, and music equipment. One type of touchless interface uses the Bluetooth connectivity of a smartphone to activate a company's visitor management system. This prevents having to touch an interface like at the time of the COVID-19 pandemic. Uh, Input device. The ability to track a person's movements and determine what gesture they may be performing can be achieved through various tools. Kinetic user interfaces, the short meaning is KUIs, are an emerging type of user interfaces that allow users to allow users to interact with competing devices through the motion of objects and bodies. Example of kinetic user interfaces include tangible user interfaces and motion-aware games such as Wii and Microsoft Kinect and other interactive projects. Although there is a large amount of research done in image video-based gesture recognition, there is some variation in the tools and environments used between implementations. Wired gloves. Uh, this this can provide input to computer about the position and rotation of the hands using magnetic or inertial tracking devices. Furthermore, some gloves can detect finger bending with a high degree of accuracy, 500 degrees, or even provide haptic feedback to the user, which is a simulation of the sense of touch. The first commercially available hand tracking glove type device was the Data Glove, a glove type device that could detect hand position, movement, and finger bending. This uses fiber optic cables running down the back of the hand. Light pulses are created, and when the fingers are bent, light leaks, small track cracks, and the loss is registered, given an approximation of the hand pose. Depth aware cameras using special cameras such as structured light or time of flight cameras. One can generate a depth map of what is the being seen through the camera at a short range and use this data approximation and 3D representation of what is being seen. This can be effective for the detection of hand gestures to their short-range capabilities. Stereo cameras. Using two cameras whose relations to another are known, 3D presentation can be approximately by the output of the cameras. To get the camera's relations, one can use a position reference such as Lexan strip or interrupt emitter. In combination with direct motion measurement, 60 vision uh, gestures can directly be detected. Gesture-based controllers. These controllers act as an extension of the body so that when gestures are performed, some of their motion can be conveniently captured by the software. An example of the emerging gesture-based motion capture is skeletal hand tracking, which is being developed for virtual reality and augmented reality application. We will use this. And also an example of this technology is shown by tracking companies' users and gestion, which allow users to interact with their surroundings without controllers. Wi-Fi sensing. Another example of this is mouse gesture trackings, where the motion of the mouse is connected to a symbol being drawn by a person's hand, which can study changes in acceleration over time with referensive gestures. The software also compensates for human tremor and intermittent movement. The sensor of these smart light emitting cubes can be used to sense hands and fingers as well as other objects nearby and can be used to process data. Most applications are in music and sound synthesis but can be applied to other fields. Single camera. A standard 3D camera can be used for gesture recognition where the resources environment would not be convenient for other forms of image-based recognition. Earlier, it was thought that a single camera may not be as effective as stereo or depth-aware cameras, but some companies are challenging this theory. Software-based gesture recognition technology using a standard 3D camera that can detect robust and gestures. Now we will talk about the algorithms because it's important things. And the other step, we will talk about challenges and next video we will implement gesture recognition. Now, algorithms. Depending on the type of input data, the approach for interpreting a gesture could be done in different ways. However, most of the techniques rely on the key pointers represented in a 3D coordinate system. Based on the relative motion of these, the gesture can be detected with high accuracy, depending on the quality of the input data the algorithms approach. In order to interpret movements of the body, one to classify them according to common properties and the message the movements may express. For example, in Sing language, each gesture represents a word or phrase. Some literature differences two different approaches in gesture recognition, 3D model based and appearance based. The foremost method makes use of 3D information on key elements of the body parts in order to obtain several important parameters, like palm position or joint angles. On the other hand, a presence-based system uses images or videos for direct interpretation. 3D model based algorithms. The 3D model approaches can use volumetric or skeletal models or even a combination of two. Volumetric approaches have been heavily used in the computer animation industry and for computer vision purposes. The models are generally created from complicated 3D surfaces like NURBS or polygon meshes. The drawback of this method is that it's very computationally intensive and systems for real-time analyze are still to be developed. For the movement, more interesting approach would be to map simple primitive objects to the person's most important body parts. For example, cylinders for the arms and neck, sphere for the head, and analyze the way these interact with each other. Furthermore, some abstract structures like superquadrics and generalized cylinders may be even more suitable for approximating the body parts. Scuttle-based algorithms. Instead of using intensive processing of the 3D models and dealing with a lot of parameters, one can just use a simplified versions of joint angle parameters along with segment lengths. This is known as a skeletal representation of the body, where a virtual skeleton of the person is computed and parts of the body are mapped to certain segments. The analysis here is done using the position and orientation of these segments and the relation between each one of them. For example, the angle between the joints and the relative position or orientation. Advantages of using skeletal models. Algorithms are faster because only key parameters are analyzed, and pattern matching against a template database is possible. Using K points allows the detection program to focus on the significant parts of body. Appearance-based models. These models don't use a special representation of the body anymore because they are derived the parameters directly from the images or videos using a template database. Some are based off the deformal 3D templates of the human parts of the body, particularly the hands. The formal templates are sets of the points on the outline of an object, used as interpolation nodes for the object's outline affirmation. One of the simplest interpolation function is linear, which performs an average shape from point sets, point variability, parameters, and external deformation. These template-based models are mostly used for hand tracking, and but could also be used for simple gesture classification. The second approach is in gesture detection using appearances-based models uses image sequence as a gesture template. Parameters for this method are either the images themselves or certain features derived from this. Most of the time, only one monoscopic or two stereoscopic views are used. Electromyography based models. EMG, electromyography concerns the study of electrical signal produced by molecules in the body. Through classification of data received from the arm molecules, it is possible to classify the action and tools input to gesture to and external software. Consumer AMG devices allow for non-invasive approaches such as an arm or leg band and connect via Bluetooth. To edit, this MAG has an advantage over visual method science. The user does not need to face a camera to give input, enabling more freedom of movement. Challenges. There are many challenges associated with the accuracy and usefulness of gesture recognition software. For image-based gesture recognition, there are limitations of the equipment used and image noise. Images or video may not be under consistent lighting or in the same location. Items in the background or distinct features of the users may take recognition more difficult. The variety of implementations for image-based gesture recognition may also case users with the viability of the technology for general usage. For example, an algorithm calibrated for one camera may not work for a different camera. The amount of background noise also causes tracking and recognition difficulties, especially when uh, occlusions partially fully occur. Furthermore, the distance from the camera and the camera relation resolutions, resolutions, sorry, and quality, also case variations in recognition accuracy. In order to capture human gestures by visual sensors, proposed computer vision methods are also required. For example, for hand tracking hand and a hand posture recognition, or for capturing movements of the head, facial expressions, or gaze direction. Social acceptability. One significant challenge to the adaptation of gesture interfaces on consumer mobile devices such as smartphones and smartwatches stems from the social accessibility implications of gestural input. While gestures can facilitate fast and accurate input on many novel form factor computers, their adaptation and usefulness are often limited by social factors rather than technical ones. To this end, designers of gesture input methods may seek to balance both technical considerations and user willingness to perform gesture in different social contexts. In addition, different device hardware and sensing mechanisms support different kinds of recognizable gestures. Mobile device. Gesture interfaces on the mobile and small form factor devices are often supported by the presence of motion sensors such as inertial measurement units. On this device, gesture sensing relies on users performing movement-based gestures capable of being recognized by the motion sensors. This can potentially make capturing signals from the suitable of low motion gesture challenging, as they may become difficult to distinguish from natural movements or noise. Through a survey and study of gesture usability, research found that gestures that incorporate sub movement, which appear similar to existing technology, look or feel similar to our action and are enjoyable were more likely to be accepted by users, while gestures that look strange and uncomfortable to perform interfere with communication or involve uncommon movement caused users more likely to reject their use. The social accessibility of mobile device gesture relies heavily on the naturalness of the gesture and social context. On body and wearable computers. Wearable computers typically differ from traditional mobile devices in that their use and interaction location takes place on the user's body. In this context, sorry, gesture interfaces may become preferred over traditional input methods, as their small size renders touch screens or keyboards less appealing. Nevertheless, they share many of the same social accessibility obstacles as mobile devices when it comes to gestural interaction. However, the possibility of wearable computers being hidden from sight or integrated into other everyday objects, such as clothing, allow gesture input to mimic common clothing interactions, such as adjusting a shirt collar or rubbing one's front pant pocket. A major consideration for wearable computer interaction is the location for device placement and interaction. A study exploring third-party attitudes towards wearable device interaction conducted across the United States and South Korea found differences in the perception of wearable computer use of males and females, in part of to, to different areas of the body considering social sensitive. Another study investigating the social accessibility of on-body projects that interfaces found similar results with the body studies labeling areas around the waist, groin, and upper body for women to be least acceptable, while areas around the forearm and wrist to be most acceptable. Public installations, sorry, such as interactive public displays allow access to information and displays interactive media in public settings such as museums, galleries, and theaters, while touchscreens are frequent form of input for public display. Gesture interfaces provide additional benefits such as improved hygiene, interaction from a distance, and improved discoverability and may favor performant interaction. An important consideration for gestural interaction with public displays is the high probability and exact or expectation of a spectator audience. Gorillarum. Gorillarum was a side effect of vertically oriented touchscreen or light pen use. In periods of prolonged use, users are begun to real fidgeted and or discomfort. This effect contributed to decline of touchscreen input despite its initial popularity in 1988. In order to measure arm fatigue and gorilla arm side effect, researchers developed a technique called consumed endurance. It's a little bit uh, high theoretical information, but next video we will implement gesture recognition in our application. So thank you for watching, and next video we will keep going our project.